This is the summary created from the video, Cloud Computing Security I. In the realm of cloud computing, security concerns are paramount when utilizing services from third-party providers, especially for mission-critical operations and sensitive data. Cloud security encompasses crucial aspects like data confidentiality, integrity, availability, and access control, governed by robust policies and data governance frameworks. The three fundamental components of security are confidentiality, integrity, and availability, collectively known as the CIA triad. Security attacks can compromise these components through various methods, including interruption, interception, modification, and fabrication. Attacks on availability disrupt access to data and resources, such as denial of service attacks, while attacks on confidentiality involve intercepting and eavesdropping on communications. Integrity attacks involve modifying data during transmission, compromising authenticity and origin. Security policies serve as guidelines, defining permitted and prohibited actions across systems, with implementation occurring in a distributed fashion across devices and components. Ensuring precise conformity between implementation and policy is an open research challenge. Attacks can take the form of deception, disruption, or usurpation of services, targeting information structures, network access protocols, and individual group or distributed systems. Security policies, models, objectives, attack models, threats, and mechanisms are interconnected components that need to be unified for comprehensive security management. Policies may conflict, leading to discrepancies that create security vulnerabilities, particularly when local and global policies clash. Addressing these conflicts and discrepancies is crucial, especially within large organizations. Security goals encompass prevention, detection, and recovery. Prevention aims to ensure that attackers do not violate security policies, while detection involves identifying when attackers breach those policies. The sooner an attack is detected, the stronger the security perimeter becomes. Recovery mechanisms involve restoring systems after successful attacks, including stopping the attack, assessing the damage, and implementing redundancy measures. Trust and assumptions underlie all aspects of security, including trusting systems and personnel. Security policies should unambiguously partition system states and capture security requirements for each state. Mechanisms are implemented to enforce policies, and support mechanisms must function correctly. If the set of reachable system states is within the set of secured states, the system is considered fully secure. Assurance involves specifications, verification techniques, and monitoring to ensure that security policies work as intended. Security assurance begins with requirement analysis, which involves identifying desired functionalities. The design phase specifies how the system will meet those requirements, followed by implementation, where systems are programmed to execute the design. Proper design is crucial for ensuring adequate security measures, and following best practices is essential for system development. Evaluating security measures involves operational and economic considerations, such as cost-benefit analysis. Factors determining the level of protection include data sensitivity, system purpose, and associated risks. Security implementation considers threats, policies, specifications, design, and operations. Human and organizational factors, like responsibility and authority, also impact the security approach. The current focus is on the provider and system perspective, considering threats, policies, and mechanisms. Passive attacks involve eavesdropping and obtaining transmitted information without modifications, while active attacks involve modifying data streams or creating false data streams. Traffic analysis involves observing patterns in network traffic to predict activities. Masquerade attacks involve an entity pretending to be a different entity for unauthorized access, while denial of service attacks prevent normal use of communication facilities by overwhelming resources. Security services aim to provide confidentiality, authenticity, and integrity. Non-repudiation ensures the finality of orders or transactions, while access control prevents misuse of resources with role-based mechanisms. Availability ensures that resources are accessible and data is not erased, as denial of service attacks and viruses can cause non-availability. Confidentiality protects its privacy loss and integrity prevents data alteration or corruption. Security infrastructure plays a crucial role in authentication, identifying legitimate users and authorization, determining permitted operations. Non-repudiation ensures the finality of orders, while safety protects against tampering, damage, and theft. Various attacks exploit vulnerabilities in these areas. Network security is a prominent scenario for cloud infrastructure security. Robust network-level security is crucial for cloud-based distributed systems. Key aspects include security policy determination, implementation, reconnaissance, vulnerability scanning, and penetration testing. The security policy serves as a comprehensive roadmap for organizations, guiding network design and configuration. Implementing security measures like firewalls, intrusion detection systems, and honeypots helps understand and mitigate attacks. Network reconnaissance, both passive and active, is essential for attack prevention and vulnerability assessment. Vulnerability scanners help identify vulnerabilities in systems and networks. Open-source tools like Nmap can scan for network vulnerabilities, while Metasploit allows exploitation of identified vulnerabilities. Vulnerability databases like NVD list known security issues, and scanners need regular updates to detect new vulnerabilities. Penetration testing assesses how deeply systems can be compromised, with safe attacks revealing vulnerability points for applying patches. Post-attack forensics investigation is guided by laws and processes for retaining evidence chains. In cloud environments, post-attack scenarios can manifest in similar or different forms compared to traditional setups. Proper procedures must be followed for post-mortem or post-attack forensics and evidence preservation. Legal and technical guidelines govern the process of post-attack investigation and evidence handling. The next lecture will examine different attack patterns and their implications specific to cloud computing environments, focusing on the security concerns unique to cloud environments. Today's session on cloud security has concluded, highlighting the paramount importance of robust security measures for sensitive cloud operations. In summary, security risks demand robust handling for sensitive cloud operations, with the CIA principles serving as core pillars for secure practices. Types of attacks range from denial of service to impersonation, and policy conflicts and discrepancies pose security challenges. Detection, prevention, and recovery form the three main security goals. Requirement analysis and design are vital for assurance, while cost-benefit analysis weighs operational and economic security factors. Attacks can be passive, like eavesdropping, or active, like data modification. Services like authentication, access control, and availability are essential. Lastly, network security practices are crucial for cloud infrastructure security. Please stay tuned for more summary videos.